Welcome to the next installment in my video series. We're going to talk about libraries now. This is probably something people have been waiting to hear about. So, without talking too much more, let's get into it. Now for reference, I'm going to add a picture of the schematic, the project we're going to be working on. So how I'm going to do that is go up to Place, Drawing Tools, Graphic. Now I'm going to go navigate to where that picture file is. And there it is. Okay, so now we have a little reference to work with. Let's start making some components. The first component I'm going to make is the input and output jacks. Since I'm going to be using a guitar or bass, I'm going to be using a 1/4 inch TRS jack. I already have one picked out to save you guys a little bit of time, so let's go through it. Right click on your project and add new to project. Schematic Library. And you're going to have to get used to navigating through these panels. I personally don't like Navigator, so let's close that. Filter I don't usually use either. But Schematic Library Inspector is very useful. So let's drag that to here and it'll snap to the side. Great. So here's our first blank component. Let's get rid of all this junk. Remove the default footprint and all of this stuff. This is what you guys are going to see when you make your first component. Nothing. But we're going to be changing that quickly. Let's first add our pins. To do that, we go over to Place, Pin. Pretty easy stuff. Let me breeze through this so I don't have to bore you guys with the details. Okay, so I have a basic diagram of the connector. Now I like to change the color of this, so select everything you want to change the color of. Go to the Schematic Library Inspector and let's go to Color. Select Standard, and then let's say this guy right here. Let's also change this. Great, I think it looks pretty good now. Go back to Schematic Library. Now this is an interesting feature of Altium Designer that I think is really great. You can actually pull live supplier data. It'll give you the stock, the price, all the specifications of the product and stuff like that. So go to System, Supplier Search, and put in the number for the thing you're interested in. I usually like DigiKey. So right click on this and add Supplier Link and parameters to your component. Is copy the description and put it here. Copy the manufacturer part number. And for connectors, Usually for the symbol of reference, I like to put the company name underscore the product name. And this is a jack, so the reference designator is J. Everyone has their own standards, but I prefer J. And whoa, this is way up here. Let's pull it down. Right. Now you might notice, why isn't the reference designator showing up? Well, go to Tools, Schematic Preferences. Actually, don't do that. Go to Document Options. Always show comment and designator. That is the correct thing to use. And where did it go? That is interesting. Okay. Sorry, it's the movement is a little jerky. It's probably the screen capture that's doing it. But here we go. Now we have the information we need. We have the diagram with the pin numbers. That will actually translate to the physical footprint on the circuit board. So these have to be correct. You have to know that. If you're having trouble with it, a lot of suppliers will help you out with it, but it's a skill that you really need to learn if you're going to be doing this a lot. It would be a very, very costly mistake if you get a board back and you did that wrong. So don't do that. So for the respective schematics, hold Control and double click into here and right click, place, part. And let's choose. Let's choose this guy. If you can't find what you just made, you're going to have to go into here, into libraries, and choose the correct library that's in your project. I already have that, so let's press OK. J1. Let's place it. It may take a second, depending on if the parts are cached in memory or not. But cool, we laid out our first component. Let's go to our schematic library, and this time let's use a wizard. So Tools, Symbol Wizard. And let's see, this is a new feature of Altium Designer. I think it's pretty neat, but I need a little bit more experience with it before I can show you how to use it properly. Let's go to Dual Inline and 2 pins. Sure, that sounds good. And let's set those both to passive. This is for electrical rule checking. So if you have an I/O pin on a device, if it's not connected to another I/O, it'll throw an error, which is useful in some cases, but we want to make it simple here. So let's do place component. I'll continue editing after placement. Place component. Yeah, sure. Well, that was the first time I actually used it, and now we know what I did wrong. Let's get rid of this. or actually select it, Control X. Yeah, something just totally got messed up. It erased all of the other pins on this device. So in that instance, close it and do not save. And let's sort by blah blah blah. There's a lot of parameters. Stock. Whatever is the most popular. Here we go. We got a 1K ohm resistor, 1%, tenth of a watt in 0603. And 0603 is an actual code name for a surface mount package. So, same thing as we did before. Add supplier link and parameters. That's pretty funny. My default is a capacitor, so now if you're experiencing this, it's probably because you're a little bit more advanced and you fooled with the defaults. So go to DXP, Preferences, Default Primitives, Part, and get rid of all this crap. Okay, so now whenever I make a new part, it won't load all of that crap. So sorry about that. Let's do it one more time. Okay, cool. So it doesn't have all the junk information. It has the correct information this time. It's a resistor, so the reference designator is R. Cool. And let's make the pins for it. Press the space bar while you're about to play something to rotate it. And if you notice this little tiny X on the end, that's where the connection is. So in this case, we want the resistor connections to be on the outside. Yeah, let's change the length of the pins. Pin 1, pin 2. And now let's draw the actual component. Change the grid, change the snap grid, let's say 50 mil. A mil is 1/1000th of an inch, if you didn't know. This is a European style resistor. You're welcome to use whatever kind of standard symbol you want. I personally like that because you can put some information inside of this block rather than having squiggles, lack of a better term. So for resistors, I don't really care about the part number, not in this instance. I want to see the resistance though. Of course that's way up here, right? Yep. Don't know why it's doing that. But oh well. I want to center it nicely. Center. Okay. Cool. So here's your resistor. We don't really care about that. It's not polarized. So here's your resistor. Let's save that. and go back to our top sheet. Now, as we're starting to configure this, I want to introduce you to footprints, everyone's favorite stuff. So, add new to project, PCB Library. Library. I can't find the origin, so let's go to View, Fit All Objects, and that didn't work. Embarrassing. Okay. Well, I can't find the origin, so let's go to Edit, Set Reference, Center. That didn't help me all that much. Well, that's not cool. Set reference, let's choose a location, whatever. Doesn't really matter because the grid is going to start from where you set the origin. You always want to put the correct grids on, and that's going to be the largest grid you can actually get away with, and you can work your way down if you want more details. We want to go to the data sheet of the component we created. So we're going to right click and click References, and it will pull up the data sheet or whatever reference it linked to from DigiKey. Panasonic, I don't particularly like how they supply their information. Blah, 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 blah. Catalog's not my favorite thing. Wonderful, they don't have a footprint on their catalog. Well, let me go make it, and I'll meet you back in a second. Here is the footprint for our 0603 resistor. Now don't get confused, because 0603 is actually an imperial code, which is used in the US, unfortunately. We still haven't gotten used to the metric system. Don't ask me. We could talk about that for a while. But 1608 is actually the metric measurement. So EIA is actually the English standard. As you see, in metric, it's a lot easier to understand. 1.6 millimeters by 0.8 millimeters. And the height is 0.55 millimeters. And the N at the end of this means nominal land pattern. There are usually 3 different densities when you're talking about making a footprint. L is least. That is when you're really, really pressed for space. I don't suggest using that typically. N is nominal, and M is most. You would go with most if you need to hand solder stuff. But I usually go with nominal because I'm comfortable soldering that as well. Alright. And here's another little trick you got here. I've made a 3D model for this as well. If you double click on it, you notice it's a generic 3D model, but I've embedded a step model that is a standardized 3D model file. You might be wondering what this green these green lines are. That is actually called a keep out, or I apologize, courtyard. The courtyard is the actual mechanical clearance that you need to maintain between the device and other devices. So if you're placing two of these resistors next to each other, you do not want these lines to overlap. The minimum possible spacing you should have between these is when the adjacent components lines are touching. So that about does it for the basics of footprints. Now, how do we get these to work together? Well, let's get back to our schematic library. Add footprint, browse, and then we can link that to the footprint. And you can see the importance of labeling your pins correctly. If you label them incorrectly, let's say you have a diode or even an electrolytic capacitor, it will be assembled backwards if you screw this up. And that could cause it to explode when you plug it in. You don't want to do that unless you mean to. So now this guy's linked. Ta-da, you're done. Just kidding. We're going to work more on this. If you got any use out of this or you have any suggestions for my future videos, let me know. I'm always excited and passionate about helping you guys out and sharing my knowledge that I have. As always, I try my best to be accurate and to prevent you guys from screwing up like I did when I was first learning it. But it's inevitable. You just do your best you can and have a lot of fun. So I'll catch you in the next video. Thank you very much for watching. Take care.